I'm Anil Kumar. Welcome to my series on understanding strategies to solve word problems. You'll also learn tricks to find the solution within minutes. In this video, we'll discuss a problem based on mixture where the item has been removed and then replaced by something else, and we need to work on such examples. These examples are very common in competitive exams these days. So I hope the methods which we discuss here will help you to solve such questions. The question here is, in 90 liters mixture of milk and water, there is 30% water. 18 liters of this mixture is removed and replaced with water. What is the percentage of milk in the final mixture? So let's look into the flow of the steps which take place, and then we'll also derive a formula and a shortcut method to find the solution. So to begin with, we have 90 liters of mixture, right? So total quantity is 90 liters. In this, 30% is water, so that means what is milk? Well, so that has milk and water. Let me write milk first and water later. So if water is 30%, then milk is 70%, right? How do you find it? 100 minus 30. Now, whenever we are working with percent could be written as a fraction or a decimal equivalent. So let me write down decimal equivalent here, which really means 0.7, and this means 0.3. So from 90 liters, how much is the milk? Well, 0.7 times 90 is the milk. So we have 0.7, right, times 90 as the milk, and we have 0.3 times 90 as water. That is the quantity of water. So when you multiply, 9 times 7 is 63. So what we get here is 63 liters of milk, and 3 times 9 is 27 liters of milk. So that is the position when we have 90 liters of mixture where percentage of water is 30%. Is that point clear to you, right? So that is the first basic understanding, right? Now let's move on to the next step. So we have done up to this point. Now it says 18 liters of this mixture is removed and replaced with water. So first is we're talking about 18 liters being removed. Now what will that mean? So 18 liters removed, that means both milk and water gets removed, right? So they will get removed in the same ratio, that is 0.7 times 18 and 0.3 times 18. That much is removed. So let me now talk about what is removed, right? So out of 18 liters, milk removed will be 0.7 times 18 and water removed will be 0.3 times 18, right? So you can multiply by 7 and multiply by 3, and we know total is 18. Well, these numbers seems to be smaller, so let's do this. 3 times 8 is 24, 2. And 3 times 1 is 3 and 2 is 4. 5.4, correct? On the other hand, you could actually subtract from 18 5.4 and get this value. So we could get 6 here, right? And then what do you get? You get 12, right? So you get 12.6 to give you 18, right? Or you could multiply by 7. So this is what is removed. Do you see that? So when we say 18 liters is removed, this portion means that you took away so much of milk and so much of water. They have to be removed in the same ratio in which they are mixed. So we're considering a homogeneous solution, right? Now this has been removed from 63, that has been removed from 27, correct? Now how much of the milk is there when you remove this? So you have to take this difference, right? So we take the difference of these two, that is to say, we do this operation. We add these two, right? So difference of these two and also difference of these two to know how much is the water remaining and how much is the milk remaining, right? So when you do the difference, you get, think this is 0.0, right? So we get 0.4, borrow from here 0, 50.4. These are only the steps to understand the whole thing, right? Here we have 0.6, right? So 27.0. So we borrowed 6 here, so we get 21.6 as the water element in this container after you remove 18 liters. Now what is done? It has been replaced by water, right? So the only quantity which is replacing it is water. So what we do here is we add 18 liters of water. Here we add nothing. So now finally what do we get? We finally will get total of 90 liters, right? So when we do this, we get total of 90 liters. And in this 90 liters, this total is 90 liters back again, since 18 was removed and 18 was added. But in this 90 liters, we only have 50.4 liters of milk. The question is, what is the percentage of milk in final mixture, right? So let's write down our answer. So simple, right? So now we can write down our answer. And what is the percentage of, last statement, what is the percentage of milk in the final mixture? So we have 50.4. So we have 50.4 of milk out of total of 90. And we are going to multiply this by 100 to find the percentage. Is that clear to you? Okay. So basically that goes, and this decimal moves to this place. We can divide this by 9, right? So that gives you 9 times 5 is 45, and then we have 54. 9 times 6 is 54. So we get 56. So 56% is the milk. We get our answer, correct? So the answer is 56%. Correct? So see, these steps, there is some calculation involved, but however, you do understand how to solve the question generally, right? Now let us look into another aspect of this, and let me call this as our method 2, right? So this is our method 1, and now we'll talk about method 2. So in method 2, what we need to consider is, in this particular case, as clearly, we had 90 liters of milk, right? Total milk 90 liters. 18 liters was removed and water was added. So that means nothing was added to milk, correct? So how much remained? Now, in option 2, we can also look into 18 liters and 90 liters. How are they related? So when I say 18 liters out of 90 liters, it means what? It means, see, 10% is 9. It means 20% removed. Do you see that? So that means 20% removed. Does it make sense? So what we have in this situation is that 20% has been removed when we remove 18 liters. Is that clear to you? So for some students who understands percent and ratios and fractions, for them method 2 is very good method. So the key here is to understand, when we say 18 liters removed from 90 liters, 10% is 9, 20% is 18, right? Now let us see how to solve this question. So our second approach here is based on 90 liters of mixture of milk and the water. There are 30% of water. Okay. So how much is final milk? So let's find milk. So milk is 70%, right? So it is, we have 90 liters, correct? 90 liters times amount of milk as we found here is 70%, right? Which is 0.7, correct? So we have so much of milk in our mixture original, correct, which we found is 63. Now look here, you don't have to multiply now. Now after removing 18 liters, so when 20% removed, it means 80% remains. So milk remains how much? Milk remains, we had 90 times 0.7, 80% remains, means 0.8. Do you see that? So much milk remains. Now the question is, what percent of milk in the final, right? So we now find percent of milk. So percent of milk will be whatever remains, which is 90 times 0.7 times 0.8 divided by 90 times 100. That is the percent, correct? 90 and 90 cancel. 7 times 8 is 56. Points go away with 100 and we get our answer, which is equal to 56%. Is that clear to you? So this second method is very, very efficient. When you look at this question, see, it doesn't take even a minute. 90 liters of mixture of milk and water, there are 30% water. So 70% milk. So 90 points times 0.7. 18 liters removed means 20% removed, 80% remains. So you multiply by 80%. You know exactly what amount of milk is there in this mixture now. To find the percent, divide by original amount, which is 90 liters, multiply by 100, get your answer. This is the fastest method of solving such questions, especially when there is a multiple choice test paper. Is that clear to you? Now, for those who find this difficult, since I have seen many students do not understand fractions and they can't relate decimals, fractions and percent. I mean, that's an irony, but many students do not understand. So for you, there is a formula based method. So let me call this as method number 3. So well, we did get 56 as our answer. So which is a formula based. So what is the formula? Formula is a very standard formula in this case. We are interested in what remains, right? So we want what remains. So remains is equal to, of course, from what we start with. We call this as initial, right? Initial, starting with what, right? Times, every time you can take this. So 1, like we did 1 minus 0.3 to get 0.7. Do you understand what remains, right? 1 minus, what is removed from total? Removed from total. So that is what remains. Do you see that? And that is what we did actually. If you look into this, the calculations shown earlier is exactly this. Now the beauty of this formula is that this formula can be applied even in the situations when we do repeated operations. What I'm trying to say here is, if I extend this question and I say that this process is repeated 2 more times, that means 3 times, then the answer will be this to the power of 3. So in this case, we write n here, where n is the number of times this process of removing and adding the same amount by another thing is done. So this is a huge formula which can be applied in many questions. And you can easily find the answer, correct? So let's apply this formula to find what remains. Now initial amount is actually 63, right? 90 liters is the total. So you have to understand, 90 liters is the total. 70% of 90 liters is the initial amount, which is 63, correct? So we have 63 here, 1 minus. You removed 18 liters from total of 90. Do you see that? And this was done only once, so only 1 will come there. Only once, right? So that is what the formula is. Do you understand the beauty of this formula, right? So now you could simplify this. This is 18, which can go 2 times and then 9 times, right? So 9 times 2 is 10. You could actually write this as 63, 1 minus. So if you divide by 2, we could divide by 9 also. So we get 2 over 10 or we get 1 over 5, okay? So 63 times 1 minus 1 over 5. If from 1 you take 1/5, what remains is 4/5, right? So 63, 5 minus 1 is 4, right? Times 4 over 5, right? So this gives you what remains in the quantity, and this quantity will be 50.4, correct? So we get the quantity which remains. Well, you will say you wanted the percent. Oh, well, one thing to show you here is what remains. If we start with the quantity, we get quantity. Do you see that? But what you wanted? You wanted percent. Oh my God. So percent was actually simpler. Let me show you, right? So now we'll do remains in percent. In percent. That means initial amount should be written in percent only. So you started with 70%. Do you understand? So we will write 70 here for 70%. Do you see that? Initial amount is 70%. And 1 minus, well, this is same ratio, 1 over 5, right? So instead of writing 18 over 90, it is 1 over 5, right? So which is 70 times 4 over 5. And that is 56. Do you see that? 5 times 1, 14, and 14 times 4 is 56. So we get 56 in a straight calculation, correct? So you don't even have to calculate the value of initial milk amount in this question. Do you understand that part? Right? So I hope this is clearly visible to you. That is how we are going to answer such questions. Now once again, let us go back to our question and see how to solve this in a minute's time, right? So the question is, in 90 liters mixture of milk and water, there is 30% water. 18 liters of mixture is removed and replaced with water. What is the percentage of milk in the final mixture? So we want to find percentage of milk, right? So percentage of milk, to understand, is amount of milk over total amount times 100, right? That is percentage of milk. So in our case, what are we given? 90 liters of mixture of milk and water, there are 30% milk. That means we have 70% milk, right? 30% water, 70% milk. So 70% of 90. So amount of milk is 70% of 90. So 90 times 0.7. Is that clear? So that becomes the percent of milk. Then it says 18 liters of mixture is removed and replaced with water. So 18 liters means 18 out of 90 is basically 1 out of 5, correct? Which is 20%. So 1 out of 5 is 20%, right? Which is 0.2, correct? So 0.2 is removed. So what remains is 0.8. So we'll multiply by 0.8 since we want what remains. And then 18 liters of water is added. So the quantity is full 90. So total amount of mixture is still 90. Do you see that? So now we can cancel 90 and 90. We have to multiply by 100 to get the percent. 7 times 8 is 56. These two decimals taken care by 100. So we get 56% as our answer. So these are the steps involved to solve the given question. This is what should be your method of preference, right? Which we called method number 2. Now let's look into method number 3, which is a formula. Amazing formula which can always be used, and the formula is this. Whatever remains can be calculated by initial value times 1 minus what is removed over total, what is removed from, to the power of n if these operations are repeated n number of times. Now in our case, we want percentage. So we know the initial percent, right? So it is 70%. Is that okay? So we are adding 70% of the milk. 1 minus, removed 18 out of total of 90. It has been done only once. So in percentage, what remains is 70%, right? And this is 1 minus, this is 1/5, right? So which is 70% times 1 minus 1/5 is 4/5. 4/5, correct? Now this can be calculated very easily. Dividing by 5 is not a problem at all. 5 times 1, and then we get what? 20. So 5 times 4, which is 20. And when you multiply 14 to 4, you get 56%. Is that clear to you? So using the formula, again, we get our answer within a minute's time. So I hope now these two methods are absolutely clear. So whenever you're working with mixture problems, you could use either the decimal equivalent or the fraction equivalent to find answer as we did in method 2, or you could use the formula and get your answer in no time. So I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.